So far we've been looking at fluid mechanics and we've talked about the various states of matter. We looked at solid, we looked at liquid, we looked at gases, and we also talked about the various concepts that relates to these various states of matter. We looked at density, we looked at the force, we looked at the area, and then we went forward to look at pressure. And in pressure, we talked about pressure being equal to the force per unit area, the force acting per unit area, and we explained the reasons why dams should be thicker at the bottom than at the base than at the top. And we said that the down, if you go down, if you keep going down, like for example, like submarines that they have to go sea diving, when they go keep going down, the pressure increases because pressure increases with depth. But now, if you are moving upward, like for altitude wise, vertical wise, if you are moving upward, like to Mars or to the atmosphere, something like that, the pressure decreases. And we explained some of the examples that we used where a deep sea diver, the case where an astronaut has to go to Mars, and we talked about all those things which are very, very important. And we looked at those various states of matter, and we said for a liquid, it's possible for the liquid to be able to take the shape of whatever container it's placed into because of the weak forces of attraction that exist between the atoms of that liquid, and also because of the very small separation distance that the kind of large separation distance that exists between the atoms of those molecules. For a gas, we said that that's the distance between two atoms, is very, very large, and the forces of attraction is so minimal, and therefore an atom of a gas can go anywhere, can occupy whatever volume um, um, we have. So we already looked at that in last class, and we already started something about buoyancy. And that's we talked about buoyancy, and we said it's a very familiar phenomenon we know today. And so we talked about if an object is immersed in whatever body of fluid, it may be water, it may be gases. We said there is a concept we can also study buoyancy when that happens. And what we're saying is that when that happens, when an object is in the fluid, there is a possibility for that object to float. And we said that that object will float because of a buoyant force that exists, that exists in that body. We can be able to see the buoyant force that exists, and it's as a result of this buoyant force that we can actually that the object can actually float. Now, one of the things we also talked about last class, we also consider the diagram that we have here. We say that the horizontal forces balances each other, and you see that when we consider the vertical forces, F2 is greater than F1. Because of that, that object can float, and that net force that exists between these vertical forces F1 and F2 is what we generally refer to as the buoyant force. Thereafter, we also went to look at Archimedes' principle, and we said that the principle is pretty clear. If you fill a jar of water with water, and you tie a rock to a thread, and you put the rock inside the water, and maybe the jar has an opening, we said that if you collect the water that is displaced by that stone inside the main jar, and then we see that if you find the weight of that water, the collected water, we say that the weight of that collected water will be equal to the mass or the weight of the stone, and that describes Archimedes' principle. And it's a very, very important principle because it applies to a lot of things. It applies to electrodynamics, it applies to aerodynamics, it applies to many fields that we can see. And this Archimedes principle also applies to both gases and liquid. So it basically applies to fluids. So we have this example here, like I explained. You have this this thread tied to the stone, and you have this jar filled up with water. So if I put the stone inside this jar filled with water, or this bucket filled with water, you see that there is a displaced amount of water collected into this other small volume, small bucket. And if I find the weight of this water inside this smaller bucket, the weight will be equal to the weight of the stone. So Archimedes' principle says that a completely submerged object always displaces the volume of liquid equal to its own volume. Or you can say that the weight of the water inside the smudge collected is the same as the weight of the stone. So this is kind of an example of an object that is completely immersed The same thing we've talking